This is Data Community United for Ukraine, and as usual, we are testing our sound. So if you can hear us, just let us know, writing that the sound is fine in LinkedIn, Facebook, or Twitter, or YouTube.
Good. I assume that's
Yes.
That's a positive. Everything's working.
Yeah, everything is working perfectly, I guess. So hello everyone again. Thank you for coming today. And I am Bogdan Maheros, and this is Data Community for Ukraine. Today we have our speaker, Chris Webb. We have co-hosts Andrea Melancia and Jan Sarka. Thank you for coming today. And let me tell you a few things what the conference is about. So today is the 8th day of the conference marathon for collecting funds for our Ukrainian Marine units who are defending our country in different places. And we are collecting funds for our Marine units who are in the hottest places in Ukraine, liberating Kharkiv, Kherson, and other areas that are Ukrainian. And our goal is a copter, a DJI Mavic 3. So people who are from Ukraine, they usually know about it. So as you know, copters are the eyes of our Marines, and our soldiers need it right now, since this is the eyes of our soldiers. So any even minimal donation is a very important investment for our defenders who need stay safe at the front line and come back alive when the war is over. And we are talking not only about technical things, not only about business intelligence. We are mentioning artificial intelligence, about clouds, Power BI, etc. And by the way, you can also register on the Eventbrite page, which is mentioned in the description of the YouTube video. So if you register there, you have a chance to win some nice gifts. So, and by the way, don't forget to subscribe to our YouTube channel, not to miss our events. So you can press notify button or subscribe to the channel, so be notified about our future events. So today we have our speaker, Chris Webb, who is a principal program manager on the Power BI customer advisory team. He has over 20 years of experience as a consultant and trainer, specializing in Microsoft BI stack and in Power BI, SQL Server analysis services, MDX, DAX, and Power Pivot and Power Query. And by the way, 1 second, let me take this thing. I guess some of you can have this amazing book. It's from 2014. We talked about, with Chris before this session. We had about 15 minutes for that. So this book is the last one about Power Query, right, Chris? But
yes.
But so it's from 2014, and a lot of things changed in Power Query. But I guess Chris tried to cover. I believe he covered the basics of Power BI and some advanced things as well. So we'll be talking about performance tuning Power BI and data flows. So I guess this is a very important topic nowadays, since Microsoft provides you like a cool infrastructure with data sets, Power with data flows, data marts, etc. So it's very important to make your reports working efficiently. And a lot of us are struggling with performance in Power BI. So Chris, your turn. What we are talking about today?
Yeah, so I'm a massive fan of Power Query in all of its forms. I think that book you showed was probably the first one that anybody wrote about Power Query. It was, from a commercial point of view, maybe a couple of years too early, but it sold all right. And I'm so pleased to see that Power Query is really successful now. Let me share my screen and let's get on with the presentation. So, right, good. You can see my screen. Good. Right. There's my blog and there's my Twitter. Subscribe to my blog, follow my Twitter. Let's get on to the important stuff. What are we going to talk about today? So we're going to talk about performance tuning Power Query. And this is a subject I've talked about in various presentations over the years. And it's always a work in progress. It's always difficult to be able to pack the important information into just under an hour. So what we're going to do today really is talk about the things you need to know to be able to performance tune Power Query. There'll be a little bit about tips and tricks and actually how to do performance tuning, but mostly it's about the knowledge you need to know about how to measure Power Query performance and then how Power Query actually works in order for you to be able to actually go away and do any performance tuning. In terms of the scope, I've tried to keep things limited. I'm only going to be talking about Power Query when it's used to load data in import mode to a Power BI dataset, or when you're building Power BI data flows. Out of scope is Excel Power Query, although pretty much everything I say here will be relevant to Excel Power Query. I'm not going to talk about Power Query in its other shapes or forms, inside analysis services or Azure Data Factory. I'm not going to talk about direct query. I'm not going to talk about Power BI data marts. So it really is just Power Query when you're importing data into datasets and Power Query inside Power BI data flows. Now, in order to understand where that fits, it's also important to understand where Power Query fits in the larger scheme of things. Because if we're talking about importing data into a Power BI dataset, there are several things that you would need to that need to happen, and there are several things that you could tune in order to make your overall dataset refresh faster. So if we have a look at this diagram and see what happens when you refresh a Power BI dataset, what happens first of all is that you take your dataset, you send a refresh command to it, and the dataset, the analysis services engine inside the dataset, then goes to Power Query to ask for the data. Power Query itself goes back to the external data sources, and the external data sources start returning data. And that could be fast or that could be slow. There could be some performance tuning you need to do there. When the data's got back into Power Query, there could be some performance tuning that needs to happen there because Power Query might be doing transformations. And then after the data's gone through Power Query back to the analysis services engine, the analysis services engine needs to take that data and build the in-memory data structures it needs for it to answer your queries. So there are three places during a dataset refresh that could be tuned. I'm going to concentrate on the middle one, which is the Power Query engine. If we're talking about refreshing Power BI data flows, it's more or less the same. Only instead of loading the data into the analysis services engine, we're basically just taking the data and dumping it into ADLS Gen 2 storage. Or at least that's what happens if you're using Power BI data flows in Pro. If you are using Power BI data flows in Premium, there's an extra stage where you could be dumping the data into ADLS Gen 2 storage and then loading the data into something called the Enhanced Compute Engine, which we'll talk about later, and then dumping the data out into ADLS Gen 2 storage. So we're going to concentrate today on just the Power Query engine. Maybe there will be a little bit about external data sources. Now, the first most important thing you need to understand when doing any kind of performance tuning is how to measure performance. Because if you can't measure performance, you can't know whether the changes you make are making performance better or worse. So the first question here is, well, how do I measure performance of the Power Query engine? How do I know how long it takes for a Power Query query to run? And I'm slightly embarrassed to say there is no easy way of doing that. But it is possible. So I'll show you how you can get around this. So first of all, let's have a look and see how we can check performance in Power BI Desktop or in a data set that's published to a Power BI Premium capacity. So if I now go to Power BI Desktop, I've got a super simple data set here where I'm just loading two tables into Power BI. Let's have a look at the Power Query queries that feed into that. For the purposes of this demo, we can ignore all of this, and we need to look at these three Power Query queries. We've got a query called dim date and two queries, Mondays and Tuesdays. If we have a look at the query dependencies, and zoom in a little bit, and again, let's ignore this stuff. What we've got is a local SQL server. I'm old school, but it works. The AdventureWorks database. And from there, I've got a query called dim date, which connects to the dim date table in the AdventureWorks DW database. This is literally just a date dimension table, so really, really simple. And then I've got two queries that reference this query, Mondays and Tuesdays. Dim date, like I said, just gives you the full date dimension table. You can see that there is an English day name of week column here. Mondays references that dim date table. And what it does is it filters that dim date table and only gives me the rows where English day name of week equals Monday. When this comes back, we'll see that we've only got the dates in my date dimension table that are Mondays. And similarly, I've got a query called Tuesdays where I only get the rows where the date is a Tuesday. So super, super simple. Now, if I was to refresh one of these queries, I've got two loaded into the data set here. Let's say I wanted to refresh the Mondays query. How do I know how long it's going to take? How do I measure how long the Power Query engine takes to connect to the data source and get the data and return that filtered table of just Mondays? I can't see it anywhere inside Power BI Desktop. What I've got to do is use SQL Server Profiler. Now, again, this seems very, very old school, but bear with me. SQL Server Profiler not only works with SQL Server, the database, it also works with analysis services. You can connect Profiler up to analysis services and see things happening inside the analysis services engine. This has always been the case with analysis services and Azure Analysis Services. But because the analysis services engine lives inside Power BI, we can actually hook Profiler up to the analysis services engine inside Power BI and see what happens when a refresh takes place. And by doing that, what we can see when the refresh takes place, we can have a look and see that, in fact, a little bit about how long the Power Query query takes as well. Now, I've got an external tool installed here. It's a community developed link to Profiler. And if I press this button, it's going to open up a new instance of Profiler connected up to the analysis services engine inside Power BI. It's going to automatically run a trace, but I don't want all of these events that it's selected. So I'm going to stop the trace and I'm going to choose just the events that I want. I'm going to select the command begin and end events. These are the events that are triggered when a dataset refresh begins and ends. And I'm also going to select the progress report, begin and end events, which give me a little bit more detail about what happens inside a refresh. So I'm going to run this and go back to Power BI Desktop, and I'm just going to refresh this table called Mondays. So I'm doing a refresh in my data set. And what's happening here is the analysis services engine is connecting to Power Query, saying, give me the output of the Mondays table. Power Query connects back to the AdventureWorks DW database inside my local SQL server, gets back those 200 Mondays, or actually 522 Mondays, and turns the data to the analysis services engine, which then builds the in-memory table that it needs. So let's have a look and see what's going on here. Now, there's an awful lot of stuff that has been generated here. Let me show you how you can get the information you need. So first of all, let me rearrange some things. Let's get the event subclass column, and let's get the duration column over here. Now, like I said, the command begin and end event is triggered when a data set begins and ends refreshing. There's a couple of other things that happen before that, but a command begin event that is followed by an awful lot of progress report begin and end events, that's the actual starting point for the refresh. Now, when the refresh happens, the first thing that happens is the analysis services engine goes to Power Query and asks for the data. Now, for a variety of reasons, it treats it as if it's running a SQL query against the Power Query engine. And the first event that is important to look at is this progress report end event, because the analysis services engine basically says to the Power Query engine, give me all of the data for that table. And that's why we see this execute SQL event. It thinks it's running a SQL query, but it's actually getting the data from the Power Query engine. Now, this execute SQL event is, well, the progress report end execute SQL event is triggered when the analysis services engine gets the first row back from the Power Query engine. And this is the duration column. This is in milliseconds. And I can see that it took almost 14 seconds for the Power Query engine to return the first row of data from that query called Mondays. Now, after that, after the first row has been returned, all of the rest of the data gets returned. And when the last of the data, all those 522 rows that we saw, gets returned, then another progress report end event is triggered, this time for read data. And this tells me it took 66 milliseconds after the first row of data has been returned to return the other 521 rows. So there are actually two events that we're interested in here to see how long a Power Query query took inside when a dataset refresh took place. Execute SQL tells you how long the Power Query engine took to return the first row of data. This read data event tells you how long the Power Query engine took after that to return all of the other rows of data. You need to look at both. Sometimes the Power Query engine is very quick to return the first row of data, but then very slow to return the rest. Sometimes, as in this case, it's very slow to return the first row of data, but then very quick to return the rest. And sometimes both take a really long time. But this is how you measure the performance of a dataset refresh in Power BI Desktop. If you want to do the same thing for a published dataset, to be able to see how long Power Query works, you do the same thing. But in that case, what you've got to do is hook Profiler up to the XMLA endpoint of your workspace. And that means it's only possible if you have premium or premium per user. So that is how we measure refresh for a data set. If we're talking about refresh times for Power BI data flows, well, the good news is it's an awful lot easier. If you go to any data flow, and I can just choose any one of these. If you go to refresh history, you can actually just see for each refresh of the data flow how long it took. You can see a duration, and indeed you can download a CSV file which has got even more information about the data flow refresh. And I've got one of those CSV files down here. We have a look at this. I've actually taken the CSV file and loaded it into Excel using a Power Query, of course, so that we can see what's going on more easily. But once we have a look at this, you'll be able to see that not only do we have the start time and the end time and the duration, we've got information about, for example, the number of rows processed, the amount of data read, the amount of time it was waiting, and whether the enhanced compute engine, which we'll learn about a bit later, was used as well. You might be thinking, hold on, we're talking about Power Query here. What about Power Query diagnostics? Doesn't that tell you how long a refresh you're taking in Power Query? Well, unfortunately, the bad news is not really. Power Query diagnostics gives you a lot of really useful information about what's happening at a low level inside the Power Query engine. But strangely enough, it doesn't actually tell you really how long a Power Query took to run. So I strongly recommend you use the profiler method that I just described there earlier. Okay, so now we know how long, or how we can measure how long a Power Query takes to run. The next thing to get your head around is what actually happens when a Power Query executes. Because this is, again, a really common source of confusion. And in order to tune performance, you need to know what gets executed. Going back to the example that I showed you earlier, where we're connecting to the dim date table in my local SQL server, we've got a query called dim date that says, get all the data from the dim date table. And then we've got two referenced queries, Mondays and Tuesdays, that just get the Mondays and the Tuesdays out. When you look at a diagram like the one we've got in front of us from the query dependencies pane, the way you naturally think Power Query queries work is something like this. You start at SQL Server, the data flows from the dim date table into the dim date query, and then it's somehow cached there or held in memory, and then filtering happens on that single copy of dim date, and the Mondays go to the Mondays query, and the Tuesdays go to the Tuesdays query. This seems completely logical, but this is not how Power Query works. So do not think of the data flowing from dim date through to Mondays and Tuesdays. That is not how things work. How do things work? Well, if we're thinking about this from the point of view of analysis services, when we refresh our data set, which has got the two tables, Mondays and Tuesdays in, analysis services treats these as, well, two separate tables that may well have completely separate data sources. It says refresh Mondays, refresh Tuesdays. The Power Query engine treats these as two separate requests. So when Mondays is refreshed, the data is got from the SQL Server database. It flows through the dim date query and to Mondays. And then when Tuesdays is refreshed, well, guess what? The data comes from the dim date table, flows through dim date, and goes to Tuesdays. So if you'll excuse the rather bad drawing, what you can see is that Mondays and Tuesdays are treated as two separate operations. And even though the diagram seems to suggest they share the dim date query, in fact, the logic in the dim date query is repeated twice. It's evaluated when the Mondays query is refreshed, and it's evaluated when the Tuesdays query is refreshed. This sounds very inefficient, but actually there's more stuff to say, which actually explains why it's not all that not all that efficient. But the key thing is, if I'm performance tuning Mondays and Tuesdays, well, there's no shared logic between them. There might be a little bit of caching in some cases inside the Power Query engine, but any logic that's inside DimDate is going to be evaluated twice. Why is this not a bad thing? Well, the next thing we need to understand is how the Power Query engine evaluates queries and evaluates the steps inside queries. This is something called streaming semantics. Now, like I said, Power Query is very, very counterintuitive. And rather than when you look at a Power Query query, you think, well, you look at the list of steps and you think it starts with the first step and then evaluates each query until it reaches the last step. What actually happens inside the Power Query engine is that Power Query starts at the end of a list of steps and goes back to the beginning. This is the key to Power Query being able to do things as efficiently as possible. And again, it's really, really important to understand this when you're doing any kind of performance tuning. I have a little demo that tries to help you understand how streaming semantics works. Let's go back to Power BI and let's reopen Power Query Editor. Now, I'm going to show you some M code, but don't be scared. It's really nice and easy to understand. This is a Power Query query that does not connect to any external data source. Instead, its source is an M list, which is basically an array. And inside this array, I have 5 numbers, 1, 2, 3, 4, and 5. So that's my data source. Not connecting to an external data source. I've just got an array, which is kind of like a table with 5 numbers in. The next thing I do is declare a function. This function is called wait_a_sec. The function takes a number, and then after waiting for 1 second, it will return exactly the same number. The next thing that I've got is an expression which takes my list of 5 numbers, 1, 2, 3, 4, and 5, and for each one of those numbers, it calls my function wait_a_sec, and then returns exactly the same number. Now, at the moment, this bit of code is not being used because my mQuery returns the output of this call function step. Now, there's the output. It's a list of 5 numbers. How long does this take to refresh? Well, I've got 5 numbers. I'm calling a function that takes 1 second to run and then returning the 5 numbers. When I refresh this, it's going to take about 5 seconds to run, which is what you would expect. So there we are. It took about 5 seconds to call a function that takes 1 second to run 5 times. So far, so good. What I'm now going to do is not return all of those 5 numbers. What I'm going to do is add an extra step. This extra step simply says take the output of call function, which is this, and just get the first number. So in effect, if this was what the query returned previously, my last step, my new extra final step, just says, okay, only return the first item in the list. How long is this going to take? Now, how long it takes is the key to understanding everything about how Power Query works. Because when I run this, it's fast, faster than before. It takes about a second. Why is that? Well, like I said, Power Query starts from the end and works backwards. So what happens is, what do I want from the output of my query? Well, it's this value, first value. First value says, give me the first n items, where n is 1, from the list returned by call function. Call function, as we saw before, takes a list of 5 numbers and calls a function that takes a second 5 times. But because Power Query is evaluating from the end backwards, it's able to do a clever optimization. It knows that I only want the first item from the list that call function returns. So, in effect, what it does is, well, let's only iterate over the first item in the list and call the function once, because I don't need the other 4 values. So this is how Power Query is able to do some optimizations. It looks at the output and works its way backwards, and then it's able to not do extra work that it knows isn't necessary. It doesn't need to call the function 4 more times in this case, because we don't need that in the output. This is something called streaming semantics. Now, streaming semantics happens inside a Power Query query, and it can also happen outside a Power Query query, because the Power Query engine not only looks at all of these operations and only does the minimum possible work, it also looks at these operations and it says, can I actually push some of this work back to the data source? If we go back to our Monday's query here, we can see this happening. Because what am I doing here? Well, effectively what I'm doing is I'm saying, connect back to the dim date table and only give me the rows where English day name of week is Monday. I could write a SQL query to do that very, very easily. And that, in effect, is what the Power Query engine has done. This is something called query folding. And in this case, I can right-click on my filtered rows step here, go to View Native Query, and I can see the SQL query that's been generated for this particular query. This is all of the logic in dim date, all of the logic in the Monday's query, converted into a single SQL query. If I go to my Tuesday's query, come back, and click on View Native Query, I'll see a different SQL query with a where clause, English day name of week equals Tuesday. And hopefully you'll agree that actually, if I wanted to load the result of these 2 tables into Power BI, this makes a lot more sense. You know, if I'm connecting to a SQL Server database, I want to return, I want to run these 2 SQL queries rather than copy the whole of the dim date table into Power BI and do filtering there, because SQL Server is always going to be much more efficient at doing filtering than Power BI or Power Query is. I can see that, I wish it didn't keep doing this. I can see that query folding is definitely happening here because View Native Query is enabled. But there is a myth in the Power BI world that if this is not available, if View Native Query is not enabled, that query folding is not happening. This is not the case. Query folding can happen quite often, and sometimes on certain sources, even though the UI doesn't give you an idea of what query is being generated in the background, query folding is still taking place. There are, of course, some transformations that you can do in the Power Query editor that prevent query folding from taking place. For example, here, I could go to Add Column and add an index column, which is basically a row number column. For whatever reason, the Power Query engine can't yet fold that back into a SQL query, and now View Native Query is grayed out. But it is still going to do some query folding. It is still going to run that query with the where clause, where English day name week equals Tuesdays, but it's just going to take the output of that SQL query and then inside the Power Query engine, add that index column. So that's query folding. Query folding is incredibly important as far as Power Query query performance goes. You need to understand when it does and doesn't happen, and generally speaking, you want query folding to happen as often as possible and for as many of the transformations as you're doing as possible. Now, query folding is only possible with some data sources. It happens with relational databases like SQL Server. It also happens if you're connecting to analysis services. It also happens with, for example, OData data sources. Different amounts of query folding, different transformations can be folded for different sources, but generally speaking, you want that to happen. So perhaps the first most important bit of advice I can give you for performance tuning Power Query queries is to check whether query folding is taking place, and if it isn't, try and change your transformations to make sure that query folding does take place. Because the more you push back to your data source, the faster your Power Query queries are likely to be. I have seen some rare cases where query folding actually results in worse performance. That's usually when you're working with quite small amounts of data and doing quite complex transformations. But I would say 99% of the time, you want query folding to happen for as many of your transformations as possible. So check to see whether query folding is happening. Like I said, view native query, if it's enabled, will definitely show you that query folding is happening. But if it's not, don't worry. You can use query diagnostics inside Power Query Editor, or more reliably, just do something like run a profiler trace against your SQL Server database to look at the queries that are actually being generated by Power Query, and that will give you some idea about what's being folded and what isn't. But make sure query folding is happening. That is going to be the key for working with really large, complex transformations. Now, this also kind of leads on to choice of data source. The last thing probably to say about query folding is that if it only happens for some sources, well, you should be trying to use a data source where query folding is possible. Query folding isn't possible on CSV files or on Excel workbooks because these data sources don't have the concept of a database engine. You can't run a SQL query against a CSV file sitting on your C drive. So using a data source where query folding is supported is going to be really important. And also, different data sources have got different performance characteristics. So choose your data source wisely. Obviously, relational databases are always going to be the best data sources to use. They're fastest to return data, and Power Query can generate SQL queries against them to take as many of the transformations you define in Power Query and push them back to the source. But if you are using a text file as a data source, generally speaking, you will find CSV files perform much, much better than JSON or XML files. And Excel files are probably the single worst data source that you can use from a performance point of view. A lot of people use Excel as a data source for Power BI, for Power Query queries, and a lot of performance problems are simply just the result of Excel being a very slow data source. If you're connecting to files in SharePoint, SharePoint itself can add an extra layer of slowness. If you're moving large amounts of data over the internet from web services, for example, that could also be really, really slow. It could be worth considering, if you've got a slow data source, taking your data and staging it in a relational database or even a Power BI data flow before you do any more transformations on it. Because getting the raw data and landing it in that data source could be fairly fast, and then your Power Query queries with all their complex transformations could be fast on top of that. Now, moving on, there are going to be some situations where the Power Query engine needs to do the transformations. You know, there are going to be cases where not all the steps could be folded, or where, for example, you're connecting to Excel files or CSV files, and you have no choice. Power Query has to do all of the transformations. If Power Query is doing all of the transformations, then you want to give Power Query as much CPU and as much memory as possible to do all of the work, because the faster CPU you've got available, the more memory you've got available, the faster your transformations are going to be. And this leads on to the question of, where are all the Power Query queries executed? And of course, it depends on what you're doing. If you're working in Power BI Desktop, Power Query is executed on Power BI Desktop. But if you've published your dataset up to the cloud, or you're refreshing a data flow, it's a little bit more complicated. If you're connecting to cloud-based data sources and you are not using an on-premises data gateway, then the Power Query engine does all of its work in the cloud, inside the Power BI service. If you are connecting to an on-prem data source via an on-premises data gateway, then, and this is not always clear, but it's a very important point, the Power Query engine does all of its work on the same machine where your on-premises data gateway is installed. So we've got different places where we can give the Power Query engine different amount of resources. If you're working in Power BI Desktop, the good news is that, let's just do that, that we've now got quite a lot of control over how many resources we give to the Power Query engine. So let me just let that go. So if you're ever in Power BI Desktop and you're doing a lot of complex work in Power Query and you find that things are slow, well, the first thing I would recommend is to go to Options and Settings, Options. When the Options pane appears, there we go. Change these settings here. This setting, the maximum number of simultaneous evaluations, controls how many concurrent Power Query queries the Power Query engine can evaluate on desktop. The other setting, which is, I think, possibly even more important, is the maximum amount of memory that each Power Query query can use in desktop. The default, I think, is 400 and something megabytes, and I've pushed up to a gigabyte here. Power Query is not guaranteed to use all of this memory, and I could put it up to 100 gig here, and I don't have that on my machine. There are some limits depending on the amount of memory you've got available on your machine and the number of simultaneous evaluations taking place. But generally speaking, I've seen some really good improvements in Power Query performance just by increasing the amount of memory available. So that's Power BI Desktop. Unfortunately, the settings you define here only apply to Power BI Desktop. You can't affect how much memory is available for Power Query in the Power BI service. If you're using Premium, you'll have more resources than in Power BI Shared, but there are no controls anymore that allow you to change how much memory is available yourself. If you're going through a gateway, however, you do have indirect control over the resources available to the Power Query engine, because these resources are calculated according to the amount of overall memory and the number of cores available on the server that your Power BI on-premises data gateway is installed on. So something I see quite a lot of is people try to be cheap and they install the on-premises data gateway for Power BI on the lowest spec machine possible. And this can cause real performance problems, because if you're doing that, you're actually going to limit the amount of memory and CPU available to Power Query when it does all of its transformations. And simply just scaling up that machine you've got your on-prem data gateway on, increasing the amount of memory, increasing the number of CPUs, can have a dramatic effect, again, on your refreshes if you're connecting to data sources through the on-prem data gateway. So everything I've said so far applies to Power BI datasets and getting data through the Power Query engine and Power BI data flows. However, there's something else we can do in data flows if you've got Power BI Premium, and that is to use the enhanced compute engine. It's now on by default, but you also need to know a little bit about how to use it, because it may or may not give you a performance boost. Let's go to the browser and go to a data flow. So what I've got here are the same two queries that get data for Mondays and Tuesdays from my local SQL server, but now I've got them inside a data flow. Data flows use something called Power Query Online as their Power Query editor. This is the kind of browser-based version of the Power Query editor that we've got in Power BI Desktop. And eventually, Power Query Online is going to replace the interface that we've got in Power BI Desktop. So it's a little bit more modern. It's got some cooler new functionality. You can see with the diagram view here, it's much easier to understand than just the kind of previous diagrams we had before. I'll let this warm up. At the moment, I'm editing the Mondays query, and in a moment, hopefully it will come through and we'll be able to see just those Mondays values. Come on, come on. There we go. So there are my Mondays. And at the moment, this is doing exactly the same as I did before in Power BI Desktop. It's just connecting to SQL Server and loading the data directly. And Mondays and Tuesdays, like I said, act as almost two independent queries. Now, what the enhanced compute engine allows you to do is to do some staging of data inside Power BI. Now, remember, at the moment, if I refresh Mondays, it's going to go back and get and fold the query and get just the run a SQL query and get just the rows from SQL Server that are Mondays. And Tuesdays is going to do the same thing, but just create a SQL query where there's a where clause where the English day name of week is Tuesdays. But I've now also, in a data flow in Premium, got the ability to take that dim date table, copy it into a data flow, and then have Mondays and Tuesdays get the data from that staged copy of the data. The way I do that is by editing the properties of this dim date query. At the moment, if I right click on it, you will see that I have not enabled the load. So it's just going to behave exactly the same way as desktop. If I select enable load, you'll see two things happen. First of all, dim date goes from being in italics to normal text. And that means that when this data flow is refreshed, the whole contents of the dim date table is going to be copied from SQL Server into my data flow. After that, it's going to be stored in ADLS Gen 2 storage, but it is also going to be loaded into this thing called the enhanced compute engine. Now, you can think about the enhanced compute engine as being kind of like a managed Azure SQL DB that sits in the background. It's not something you can see, not something you can query directly, but my Mondays and Tuesdays queries can query it. And you can see that the icon on Mondays and Tuesdays has changed. It's got this little Harry Potter-like lightning flash. So when I enabled load for dim date, the data for dim date is going to be loaded into the data flow, loaded into the enhanced compute engine. And Mondays and Tuesdays are going to get their data from this staged copy of the data. Now, because the enhanced compute engine is effectively like an Azure SQL database running in the background, query folding still takes place, but now query folding takes place on that staged copy of the data inside the data flow. Now, this can be a good thing. It can be a bad thing. If we're connecting to a very slow data source, it's probably a good thing because you just want to be able to copy all of the data once, stage it inside the data flow, load it into the enhanced compute engine, and then if we have multiple queries going against it that try and get just Mondays or just Tuesdays, going against that single stage local copy, that is going to be much more efficient. But taking the entire data for the dim date table, copying it over into the data flow, and then staging it and loading it into the enhanced compute engine, that has some overhead as well. So it could be that doing this actually makes my data flow slower rather than faster. But you just have to test. It depends. There is also one other thing here to mention while we're in a data flow. Data flows are quite good in that they will also tell you a little bit more about whether query folding is taking place. This is something I should have perhaps shown earlier. But if we go back to what we were doing before, I'm getting just Tuesdays, and let's also disable the load here. We not only get to see whether view native query works, but we actually get little icons next to each step telling us whether query folding is taking place. And this icon hasn't refreshed yet, but this icon is going to tell me now that yes, query folding is working okay. But if I was to add a column like an index column onto this again, which is, if you remember from when I did the demo before, will actually stop query folding taking place. We actually get a nice red icon here telling us that query folding is not happening. The other thing that we've got exclusively available in data flows are query plans, which are not quite as useful as you might think, but still fairly handy. If I right click on a step, I can go to view query plan. And this will give me an idea of how much of my query is folded back to the data source. And you can see here that I've got my data source here. I've got something called value.native query, which is running the SQL query that you saw before. And then the data is streamed from that into this step, which just adds the index column. So query plans can be quite useful as well. All right, so we've seen that the Power Query engine needs a certain amount of memory. Actually, we talked about that. The next thing to think about is buffering. So understanding buffering is really, really important, because I would say if query folding is not taking place, the vast majority of performance problems in Power Query happen as a result of buffering. Buffering can be a good thing, it can be a bad thing, but it depends. So what is buffering? If we are connecting to a data source like a CSV file, where query folding is not taking place. In some cases, all we need to do is just continuously read the data from the source, stream it into the Power Query engine, and then do transformations on that data as the data arrives, and then spit the transformed data out. Filtering is a good example of this. If my dim date table that I've just been working with was just in a CSV file, well, if I wanted to just get the rows where the English day name of week was Monday, I could just start reading the data from the CSV file, apply the filtering while we're reading the data, and then just spit the result out. So I never need to have all of the data in memory in order to do that filter. However, there are some types of transformation where all of the data from the source does need to be buffered into memory in order to be able to do the transformation. A sort on a table is a great example of this. If I need to be able to sort a table, I've got to buffer the entire table in memory before I can sort it. Now, buffering the entire table in memory is going to be a problem if I have a very large table. And if you remember, each Power Query has got a limited amount of memory that it can use. And if I go over that, well, what happens is we either get errors or, more likely, paging starts to happen. And if a Power Query uses more memory than it's actually able to, it's actually allowed more physical memory that's allowed to do, and paging starts happening, that is disastrous from a performance point of view. So we really need to be able to increase the amount of memory as much as possible, or we need to be able to avoid transformations that require buffering. It's pretty hard to do in terms of sorting, but in terms of something like a merge, a join between two columns, by default, Power Query will try and buffer all of the data in memory. But there are some settings, and I've got a link to a blog post later on, where in some cases, if you're joining on two columns that are actually sorted, you can actually stream the data. Buffering can be bad for performance. Buffering could be good for performance, again, if you've got a very slow data source. And you can actually manually trigger buffering in M code by writing using the function table.buffer. The other key thing to bear in mind is that if you're buffering a table in memory, the size of that table is going to be really, really important. And if you can reduce the size of that table before you have to buffer it, then you can reduce the memory overhead, and therefore you can actually improve the performance of the transformation. So if you're doing a sort on a table, the most important thing you can do is remove any columns that you're not interested in using or any rows that you don't need before you apply that sort transformation, because by doing so, you're going to reduce the size of the table, you're going to reduce the overall memory overhead of the transformation, and you're going to reduce the chance that any paging is necessary. All right, we're coming to the end. It is worth mentioning that there are some connector-specific settings that can make a big difference to Power Query performance. I'm not going to go into too much detail here because they are sometimes a little bit obscure. For example, if you're connecting to files in Azure Data Lake storage, there is a non-default option that allows you to use something called hierarchical navigation. By default, if you connect to Azure Data Lake Gen 2 storage, the Power Query engine will see all of the files in all the folders in the container you connect to. If you've got a lot of folders and a lot of files, even just reading that metadata for the first time can be super slow. So turning on the hierarchical navigation option just limits the amount of metadata that the Power Query engine accesses, and it can make a noticeable change to performance. Apart from that, well, there are going to be some other options on other data sources. Check out my blog and check out the links. I'll make the slide deck available afterwards. So if you are using one of these sources, there'll be a blog post that could be worth reading. There also are a couple of fairly obscure tricks that you can use which will improve performance. Again, I'm just going to link to blog posts because I don't think it's really important to show them here. But to call out one, if you're loading data from text files and folding's not happening, sometimes it can be really useful to do a remove duplicates before you join two tables together, simply because the Power Query engine can remove those duplicates very quickly and then do the join much more efficiently than if you hadn't. The last thing, though, that I want to call out is perhaps one of the most practically useful things. And it's understanding what happens when you do a refresh in Power BI Desktop. Because if you do a refresh in Power BI Desktop, quite often it's slow, and quite often it may be slow because of stuff you didn't expect to actually happen. There are two things that can go wrong that can kind of make Power Query performance slower in Power BI Desktop. And these things only apply to Power BI Desktop, not the Power BI service, but they're really important from a performance point of view, because if your development experience is really slow, yeah, that's pretty bad for your productivity. Now, the first thing that happens is that, well, let's go to, that's my last slide anyway, let's go back to Power BI Desktop. And let's do a refresh on Mondays here. So when I do a refresh, you'll see there's this evaluating phase. And when that's done, you can see it's creating the connection and loading the data to the model. Sometimes that evaluation phase can be really, really, really slow. What's happening then? Well, it's these two things that I'm talking about. When the analysis services engine asks for data from the Power Query engine, it's loading data into a table. And in order to load data into a table, the analysis services engine needs to know the schema of the table that it needs to load data into. You know, we've got a table of data inside my data set. What columns does it have? What data types does it have? So in order to get that information, it will go back to the Power Query engine to ask for that information. How does the Power Query engine know what columns are available in a query and what data types are available? Well, it's got to actually run the query. But it will actually only it'll not get back all of the data. It will run the query with a top N filter applied. Sometimes it's a top 1000 query, sometimes it'll be a top 4096 query, sometimes it'll be like a top 0 query. But it will run that top N query in order to understand the schema that is being returned. And that could be very, very slow. If you're running a top 1000 query against a view in SQL Server, and that view is super slow to do that, well, that's going to be almost doubling perhaps the time it takes to load the data into Power BI, because that top N query will be run and then it will go away and ask for all of the data. So that's a common source of performance problems. It is possible to work around that with some really, really complex M code. And again, I've got a link to my blog, but that's not something that you can really ever do anything about. But there's another final trick that I'll show you, which I have seen that is really easy to understand and can make a massive difference to the performance of your refreshes in Power BI Desktop. Because something else happens in Power BI Desktop when you do a refresh. If we go to the Power Query Editor window and we have a look at our Power Query queries, and I click on a query, I can click on a query and immediately it will show me a preview of the data. If I click on a step in a query, it will immediately show me a preview of what the data looked like at each step. When you do a refresh inside Power BI Desktop, it not only loads the data into your data set, but for every step in every query, it will go away and recalculate these previews. Now, if you've got a lot of queries which have got a lot of steps and you've got a really slow data source, rebuilding all of these previews for the Power Query editor could be incredibly slow. It could take way more time than actually just refreshing your data set. I've seen cases where refreshing the data set should only take 30 seconds and rebuilding all of these previews actually takes almost an hour. So how do I stop that happening? Well, it turns out there is a switch for that. So again, if you go to File, Options and Settings, Options, when the Options dialog comes up, you need to have a look at the background data settings. By default, this option is turned on, and this always creates all of those previews when you do a refresh. There are two other options. You can turn this off completely for all files, or you can use the option that I've got set here, which is on a file-by-file basis, decide whether you want data previews for the Power Query editor to be calculated every time a refresh takes place. With this middle option selected, I then also need to go to Current File Data Load and then check or uncheck the box here. But these data previews will be on by default. If you turn this option off, then the data previews will not be pre-calculated every time you do a refresh, and your refresh in Power BI Desktop could be a lot faster. So if you've got a really complex set of Power Query queries, I strongly recommend you turn that off. It will hurt your development experience in the Power Query editor because you'll start to see these yellow boxes saying preview not available. You can refresh the previews manually if you want, but it can vastly improve the performance of everything else. Right, that's it, pretty much. I finished. It looks like there are some questions in the chat, and I'm happy to take them now.
Yeah, we have a lot of questions, so we collected all them into our Zoom chat, so you can read, or we can help you starting with the first one. So the first one is idea: add FTP, SFTP, SSH connector to data flows. A lot of organizations exchange files using FTP.
Yes, I would love that. Unfortunately, I'm not in charge of adding that as a connector, but I agree that would be a really useful thing to have.
Yeah, the second one is the metrics are only shown for premium data sets. I guess this is the question related to the metrics that you showed for the data flows.
Well, the basic metrics are available all the time. You'll always be able to see the overall duration, but some of the more advanced things are only available with premium. For example, the metrics about the enhanced compute engine are only available in premium because the enhanced compute engine is only available in premium.
Yeah, Andrea, the next question is from you.
So yes, so my question is fairly simple. So we have a lot of connectors like SQL Server connectors, SQL database, etc. So a lot of different smaller versions of all of this. My question is there any kind of optimization between them? What can we expect? Are they all the same? Do they just have a nice wizard, or do they actually have some optimization for query folding, something like that?
That's a good question. I think they are all the same because I think they all use the same connector. That said, I know that there is a separate Synapse connector that is being built, which will probably behave differently. And there could be different things that fold to different versions or different flavors of SQL Server. So there's at least two connectors out there for SQL Server related data sources which could behave differently. And the main SQL Server connector, which is used most of the time, that could behave differently. I don't know. A lot of people ask what folds and what doesn't. That's not documented anywhere because it can change all the time. And it does change all the time. And the only way to know what folds or not is just to test it.
Okay, next up, we have some comments from Dan.
Okay, my comments are for that example in Power BI desktop query folding and two separate queries, Mondays and Tuesdays. I think in this case, this was kind of a bad example. In this concrete case, the performance would be much better without query folding, because you are selecting one day in a week, which is 14% of rows. No way that you would get an indexing. So you would get actually two full scans in SQL Server instead of one scan without query folding and then selecting data from the full date table. The only way how to optimize this query folding would be to have a clustered index on English day name column, or even better would be if you would do also the projection, select only really columns you need. And if query would be narrow enough, only a few columns, you might create a non-clustered index with English day name as the key and other columns included, and then you would get two partial scans, 28% of rows scanned in a non-clustered index, which is more narrow, so it would be even more efficient. So in this case, I mean, your example has shown exactly the opposite when query folding was hurting the performance.
Well, two things I'd say about that. First of all, if query folding is happening, you can see which queries are being generated, and you probably want to go in and optimize, build appropriate indexes for that. So, it's not a matter of just accepting the SQL as you've got. Well, you know what SQL is being generated, so go and optimize it. The other thing is, it's not just a matter of returning the entire dim date table or running two separate queries. If you're not folding, then you've got to get the whole of the dim date table, send it over the network to the Power Query engine, and then do the filtering there. And I absolutely guarantee that whatever the worst performance you're getting in SQL Server is, it's going to be a lot worse to take the entire table over the network to the Power Query engine, load it into whatever Power Query does, and then do the filtering there. So even though it's kind of slightly more, from a SQL point of view, it may not be all that efficient. Power Query is nowhere near as good as the SQL Server engine, even at its most inefficient, to do any kind of filtering. So I would always prefer to do that folding. And especially if it's going to be a very large table, remember you're kind of limited by the memory constraints of the Power Query engine as well. So it could get a lot worse.
Okay.
But I'm not going to argue with you about sequence performance tuning, because that would be a pretty stupid thing for me to do.
So, by the way, the next question is a question about when you have your queries, you can actually, so you had the first one for the dates table, and then you reference to Mondays and Tuesdays. But I think that the question here is, what is the difference between referencing and duplicating? I think that's pretty much what the question is asking.
This is actually quite a complex question to answer. The main difference between referencing and duplicating is all about code reuse and not performance. Referencing just allows you to write the code once and then use it in lots of different places. So that's the most important thing to say. Does referencing reduce the number of queries to the source system? Not necessarily. It could do. It depends on the source, because the Power Query engine sometimes does caching for some data sources. It won't do it for SQL Server, but it would do it for a web service, for example. And also, if you've got two queries that, like I've got, that reference like one single query, a lot depends on the amount of parallelism that happens inside the Power Query engine. Because if there is some caching that happens, which, like I said, it may or may not happen. Let's say, and if we go back to, let's imagine that, actually, let's go back to here. This is easier to see with the diagram. So we've got Mondays and Tuesdays and dim date. If I was connecting to a web service and I knew that caching was happening, then when the dim date query was evaluated, actually, even without the enhanced compute engine, it would actually cache the results locally on whatever machine the Power Query engine was running, and then use that as the source for Mondays. Now, would Tuesdays benefit from that? Yes, if the Mondays query finished before the Tuesdays query started. But if they're both run in parallel, well, they'll both be running at the same time, and one won't be able to benefit from the cache generated by the other. So in some cases, you can actually limit the amount of parallelism in the Power Query engine and improve performance because you'll improve cache reuse, but it just gets horribly complicated. So in general, I would say referencing probably will not reduce the number of queries to the source system, but it might do.
Yeah, and the question in general, would it improve performance if we will use Python code for filter CSV files?
That's another good question. Maybe, maybe not. Python would be executed on the gateway machine, and that could be more efficient than the Power Query engine. But Python can only be executed on a personal gateway, not a regular on-prem gateway, which is a bit of a limitation. And you're also very limited, I think, in the libraries you can use in some cases. So it could, but there are going to be other limitations as well.
Okay, the question.
And in general,
yeah.
In general with Excel files, they're always going to be slow to read from, regardless of who's doing the reading, I think.
Okay, and the question from YouTube. View native query isn't always a reliable indicator of folding.
Correct. If view native query is enabled, you are sure that folding is taking place. If view native query is not enabled, well, query folding could be happening or it could not be happening. So you can't use view native query as a way of saying that query folding is not happening, because even if it's disabled, it might still be happening. The only thing you can do is look at your data source and, like, for example, you might run a profiler trace against SQL Server and see the SQL queries that Power Query is generating. That will tell you what's being folded. If you're connecting to an OData data source, you can use Fiddler and look at the requests that are being made. That will tell you where the folding is taking place. Some sources that support folding, it may not be possible to do that. You can also look in Power Query query diagnostics, and that will generally tell you the thing that the query output that is being folded. So that would be SQL in the case of SQL Server, or the URL if you're folding to an OData source, or if you're connecting to Azure Data Explorer, it would be generating a KQL query. So yeah, that's one of the cases where the Power Query query diagnostics is useful, but it can be quite difficult to interpret what you see in Power Query query diagnostics.
And we have a good comment. Never argue with Dan. I'm not sure
Yes.
who is directed to, but we never argue with Dan. I can say for sure I never argue.
It's
Yes.
our old friend Paul Turley. Nice to see that Paul was also here.
Hello, Paul. Nice to see you.
And I have a question. Power BI embedded will behave similarly, or it's entirely different beast?
It would behave exactly the same.
Okay.
As far as I know. I mean, I'm not perfect. I don't know everything, but I'm pretty certain that Power BI embedded is going to behave exactly the same as the regular Power BI service or a premium capacity.
Yep, thank you. So we are out of our questions. So just there are some comments about not arguing with Diane.
Yeah.
And
nothing about chips, and but not arguing with that.
And about trusting the logs.
Yes. So in full, not argue with Dan, but trust the logs.
Yes. I mean, you can actually look at the Power Query diagnostics logs as well. They're there as text files, but I've never, the things you see in there are broadly the same as what you'd see in the query diagnostics. And I'd probably rather look at the query diagnostics.
Yeah. Thank you for coming today, Chris. Thank you for the great session. It was amazing. And thank you for everyone who asked the questions. Don't forget to donate to our defenders who need additional eyes at the front line and have to come back alive home to their families when the war is over. And we believe that it will be very soon. And we hope to see you all here in Ukraine, since we have different interesting technical communities like data platform, Power BI, some clouds user groups. So we all hope to live normal life very soon, but for that, our soldiers need a lot of equipment. Thank you for coming today, Chris, Andre, Dejan, Katalin. Thank you for supporting us. And tomorrow we have the last day of the marathon. So, and we are happy to host Leila tomorrow. She'll be talking about analytics in Power BI using AI. Okay, thank you. And I hope to see you tomorrow.
Absolutely. Thank you. Thanks for having me. Stay safe.
Thank you, everyone. Thank you, Chris.
Thank you, Chris, Bogdan. Thank you, everyone. Hope we see you all tomorrow.
All right. Bye-bye.
Some later time in Ukraine. Everybody.
Absolutely.
Yeah.